Hello everyone, welcome back to my YouTube channel. So today we are going to solve day 4 problem of this month on LeetCode. Before starting, if you guys haven't subscribed my YouTube channel yet, then please go ahead and subscribe it. Now without any delay, let's get started with today's problem. Problem number 2211. Count collisions on a road. So this problem is actually very good, very interesting problem, right? So once you understand the logic, you will find this problem very interesting, right? So here in this problem, there are n cars on an infinitely long road, right? The cars are numbered from 0 to n minus 1 from left to right, and each car is present at a unique point. So let's say this is a long road, right? This is a long road, and in this road we have cars numbered from 0 to n minus 1, right? 0 1 2 3, something like this, right? From left to right, and each car is present at some unique point. Clear? You are given a zero indexed string directions of length n. Directions of I can be either L, R or S. So here we can have L, we can have S, we can have R, we can have L, something like this. So this car is like this. Stop means here just stop. Right means moving in this direction. Left means moving in this direction. Okay, you can understand it like this, right? Okay, you are given a zero index string directions of length n. Directions of I can be either L, R or S, denoting whether the ith car is moving towards the left, towards the right, or staying at its current point respectively, right? Each moving car has the same speed, right? Same speed. Okay. Now the number of collisions can be calculated as follows. So when two cars moving in opposite directions collide with each other, right? One is moving to the right direction, one is moving to the left direction. So when two moving cars moving in opposite directions collide with each other, the number of collisions increases by 2, right? So done and done and dusted. Both are done and dusted, right? So here we have to increase the number of collisions by 2, right? When both the cars are moving in opposite directions, right? When a car moving when a moving car collides with the stationary car. Okay, when a moving car, so let's say right, and here we have stationary car, right? This is one case, or this is one case. Now here we have stationary car, and here a car is moving to the left direction, right? So I only think about these two cases right now. So when a moving car collides with a stationary car, the number of collisions increases by 1, right? So only this car is moving, right? So this car is done and dusted now. Okay, same way, only this car is moving, so this car is done and dusted. This is a stationary strong car, you can say. Okay, nothing will happen to this one, it's stationary, right? So when a moving car collides with the stationary car, the number of collisions increases by 1. That's it. Now after a collision, the cars involved can no longer move and will stay at the point where they collided. So once they collide now, so this is also going to become S, 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 right? So after a collision, the cars involved can no longer move and will stay at the point where they collided, right? Other than that, cars can't change their state or direction of motion, right? So once they collided, right? And we have to return the total number of collisions that will happen on the road. Okay, very interesting problem, actually. Very interesting problem, right? So see here, let's see these examples a little bit later on. So first see these constants. Direction dot length from 1 to 10 to the 5, and we have only these directions L, R and S. Okay, now I will give you few scenarios. Let's say this is a scenario. So that simply means here one car is moving to the left direction and other is stationary. So no collision, right? No collision here. So number of collisions is 0. Clear? One car is moving to the left direction and one is stationary. They will never collide, right? This will continue moving this direction and this is stationary. So no collision occur here. Okay. Same way here, L, L, S. Here also, this is moving to left, this is moving to left, this is stopped. So here also no collision, right? No collision, right? So now third case, let's say we have S and R. So one is stopped and one is moving to the right direction. So here also no collision, if you notice, right? There will be no collision, right? Same way here, let's say S and R, so here also there will be no collision, right? No collision, right? So now here if I write something like this, let's say I combine this case and this case, LL and S and S and R. So now in this case also, here these cars are moving to the left, two stopped cars, and here these cars are moving to the right. No collision again, right? No collision here. So from here, one point that I proved is that if we can easily ignore all the L's and all the R's in this side, because these will never collide, right? So here, what is the point that I'm making here? I'm saying skip cars that never collide. So we can remove leading L's and trailing S, right? Okay, we can remove. And if you notice one more thing here, right? So whenever two cars collide, right, one is moving and one is stationary, there will be no impact on this S, right? There will be no impact. So when a moving car collides with stationary car, the number of collisions increases by 1, right? So there will be no effect on the stationary car. And these are, we are changing it to S, right? Here when two moving cars are colliding, right, they are moving in opposite direction, then number of collisions increases by 2, right? This is one important point, just keep it in mind. Okay, so this is one thing that I noticed here, right? Skip cars that never collide. Okay, okay. Now let's see sixth case. Let's say L and R. So here one is moving to left and one is moving to right. So here also there are no collisions, right? We can easily remove leading S and trailing S. Okay, so this is done, right? Let's move to something else now. Let's say R and L. So now this is R, this is L. So here output is 2, right? Because these two cars are colliding with each other, right? These two cars are colliding with each other. Okay, now let's say this case R, S and L. So now tell me what is going to happen. How many collisions will be there? Only two collisions will be there, right? One is these two will collide, so in that case this is going to become S and this is already S. Then after that these two are going to collide, right? Then this is also going to become S. So one collision is here, one collision is here, total two collisions, right? So R is going to be impacted with this S and this L is also going to be impacted with this S, right? Okay, so these are the two things actually I need to keep in mind, right? So here if you notice now, let's see these examples. Okay, so here I can write it like this: right, right. So right means this direction, then a left means this direction, then right means this direction, then stop, then left, then left. Okay, so there are no leading L's and trailing R's, so we can't skip, right? Now here see, in this every car will collide, every car will collide actually in this, right? Every car will collide, right? And you know that there is no impact to this S, there is no impact to this S, right? Whenever the car collides, right? But other than this, all cars will collide and all these values will be changed to S, right? This brown color. So how many values I am changing here to S? 1 2 3 4 5. That's it, that's it, right? That's it. So definitely all these cars will collide in the future, right? Because we have removed the leading L's and trailing R's, because only these will not collide, but other than this all will collide, right? So these two will collide, so effect is 2, right? And then after that this and this will collide, so effect is 1. This and this will collide, effect is 1. This will also become S. Then later on this and this will also collide, so effect is 1 2 3 4 5. Or you can simply do one thing, just check after removing all the leading else and trailing r's, just check all the different values which are not s, right? And just give the count to them, right? 1 2 3 4 5, that's it. Okay, let's see this case. Leading else remove, leading r's remove, there is nothing left, that's it. Okay, now that's it, very clear, simple logic, right? Let's say this example, ll, um, R S R S L R S L L. Okay, and here let's say R R, right? So if you notice, L means this side, R means this side. So these will never collide. These will never collide. Okay, and inside this 1 2 3 4, 4 is going to be output. Other are simply S. Simple, I can return 4 here, right? Now I can prove, right? So here one, this collision, so this is going to become SSS, so one impact, right? Then this is going to be one collision, right? Right, one, and here left and right both will collide, so here impact will be two. Or simply you can just check all the known S values in this and just return that. That's it, very simple, very simple, right? This is what we need to notice, very interesting thing, right? All the cars will collide definitely, right, after removing this leading L's and R's, right? So let's write the code, very simple. Okay, so let me just maximize the screen. So here what you need to do, int n is equal to, copy this directions, paste it here, directions dot length, so I'm just calculating the length of this, and then take left is equal to 0 and take right is equal to n minus 1, right? Now here I'm telling you that we have to skip cars that never collide, right? So we have to remove what, leading else and trailing r's, right? This is what we need to remove, right? So that's my plan here. So here I'm just going to run one while loop while my left is less than n, and here directions dot char at this particular left, right, left value, if it is equal to L, right, capital L, then in that case I will just do left plus plus, because I'm skipping this, right? Left plus plus. Same way, same thing here, you have to copy this and you have to write for the right. Okay, so here you can say while your right is greater than equal to 0, right? Because right is starting from n minus 1, right? So right is greater than equal to 0, and directions dot char at this right, if it is equal to capital R, then in that case you have to do right minus minus, that's it. Okay, this is done. Now you have to calculate the number of collisions, so here just create one variable int collisions, right, and just set it to 0. Now here I told you that all cars between left and right that move, right, L or R will collide, right? They are not stationary, they will collide, right? So here I'm just going to run one loop int I is equal to left, I is less than equal to right, and here I plus plus, right? And here if, and what I'm going to do, if directions dot char at, right, I'm going to copy this directions dot char at this index I, right, if this value is not equal to your s, right? So in that case just you have to do these collisions, right? We have, so you have to just increment this value collisions plus plus, right? And in the end here you have to simply return collisions, that's it. Now let's run the code and see if there are code issues. So see, all the test cases has been selected, right? Now let's submit it. So see, our solution is selected, right? and the time complexity for this problem is going to be of n only, right? So I hope that you guys are able to understand today's problem, and if you guys still have any doubts, then please feel free to ask in comment section. Till then, keep coding and keep practicing. Meet you guys in the next video. Thank you. Bye bye.